Welcome, physics friends, to 3.3, which I have entitled How to Relate Position, Velocity, and Acceleration versus Time Graphs. Within the Chapter 3 material, this is probably the most difficult thing to understand. So I want to make sure that we do a really good job of watching this, and we're going to spend a couple of days sitting on this material because it is a little bit challenging. So what you're going to be talking about today, I've got an example sitting right in front of you. I've got a velocity versus time graph, and I started out with something very simple. And what it's going to be asking you is create the other two graphs. For instance, what if you're walking at 1 meter per second for 4 seconds? Could you make a position versus time graph? And then could you make an acceleration versus time graph? And the answer is yes. This one's very simple, and there's a couple of schools of thought to this. There's a cookie cutter method that we go through, or you can kind of use a little bit of common sense and logic to do this. We'll first of all go through the common sense and logic. If you go at 1 meter per second for 4 seconds, that means that you went that means that you traveled 4 meters from wherever you started, and you're also not accelerating. So first of all, I could probably make these two graphs. So my position versus time graph, if I started at the origin, that means I would travel 4 meters at a constant rate, so it would look like this. Now, I don't have to start at the origin. That's the first essential understanding. Is just because you have a velocity, it doesn't tell you where you start. So I could have started here at -4 and moved to the position 0. That would give me the exact same velocity of 1 meter per second. So this is actually translatable up and down. So I can start it here at 0, I can start it at -2, I can do whatever I want with it as long as I have a displacement of 4 meters. Now my acceleration is actually very simple, and you're just going to draw a straight line. Now, if the logicking doesn't work for you, I want to give you another method for doing this, and this method will work for all of the ones that we're going to do today. When you go from this graph, from the velocity versus time to the position, so from velocity to your displacement graph, it's always the slope. I'm sorry, not the slope, it's the area. You probably, that's a little bit funny. What do I mean by the area? I mean the area underneath the graph. You maybe didn't notice this, but if you go 1 meter per second for 4 seconds, the area underneath the graph to the 0 point, to the origin, this has an area of +4. That area is always your displacement. Your area equals your displacement. So if I started here at -2, my displacement is 4. And it also works when you go this way. When you go from this graph to this graph, when you go from acceleration to velocity, it's also the area. Look at the area underneath this graph. Underneath this graph to the 0 point, the area of this underneath that is 0. That area equals your change in velocity. Just like this area equals your change in displacement. So I started at -2 and I went up to +2. Since I have an area of 0, that means my velocity doesn't change. My velocity started here at 1 and it also ended here at 1. So the areas underneath the graphs when you're going from acceleration to velocity, or if you're going from velocity to displacement, the area underneath them tells you the change in that graph. Okay? That's a big one. The area equals the change. That's important. Now, what if you're going the other way? What if you're going from this graph to this graph? So you're going from the displacement graph to the velocity graph. It's the slope. The slope at each point equals the velocity. Now, for instance, in this graph right here, the slope at every point is the same because it's a nice straight line. The slope is I go up 4 over 4. So my rise over my run, up 4 over 4, 4 meters in 4 seconds. That's 1 meter per second. See how the slope is the speed? See how I've got a line here at 1? The slope is the speed. And then when I go from this graph to this graph, you use the slope as well. When you go velocity to acceleration, the slope equals the acceleration. Because the slope is how much it changes. Remember that velocity is how much your position changes per second. And your acceleration is how much your velocity changes per second. The slope here is 0. That's why this is at 0. The slope here is 1. That's why this is at 1. Your slope is it. Now, it's a very important thing to know the difference between going from your areas and going from your slopes. When you're doing a slope, rise over the run, the slope of this, it is the velocity. The slope of this is the acceleration. The area is the change. My area underneath here, if you remember back, the area was a positive 4. I don't make a line at 4. That's not it. You would be confusing the two. The area is the change in how much your displacement you've been displaced. Your area of your acceleration is how much the velocity changes from where it starts. So here we're going to do a bunch of examples, just me applying these simple rules, and hopefully you get the hang of it. We're going to spend some time doing a bunch of examples, and these are a little bit challenging, but hopefully you start to see a pattern in how I'm doing this, and it becomes like second nature to you. Here we go. My first one, when I go, so from this graph to this graph, I'm going to use the slope. This graph just means I'm staying put at the 2 meter mark. So my velocity is going to be 0 because that makes sense, but my slope of this one's also 0. My slope of this is 0, and then I go from this graph to this graph, it's also the slope. If I'm not moving, that means I have no acceleration also. A very simple graph, probably the most simple graph you're going to get. Standing still. No speed, no acceleration. Here, we're moving at a constant rate. So again, the slope. The slope of this, it looks like I go 4 meters in 4 seconds. So my slope is going to be 1. 4 meters per 4 seconds. And if you look at it, 4 meters in 4 seconds, you'll see meters per second, 1 meter per second. So I come over here at this line, and I'm going to draw, I'm trying to keep myself color coordinated here. 1. And then I go from this one to this one. Again, it's the slope. Here you've got this slope is 0, so I've got an acceleration of 0. The next one. Again, slope. So my slope here, it looks like I go down -8 meters. Stay away from the word down, because down means this way. This could be meaning north, south, east, or west. So people, I even get in the habit of saying it, but try to not say up and down. Say it's going -8 meters in 4 seconds. So that's -2 meters per second. So I've got a velocity of -2 meters per second. So again, my slope here is 0, so I have no acceleration. Very simple. Let's get to a couple more complex ones. Now we've got curvy lines. So if you look, remember, it's always the slope. So if you look at these first 2 seconds, my slope is equal to 0. Now, look at this part right here. The slope is equal to 0. And then look at this part right here. I have a slope of something. I don't know what it is, and this is a little bit debatable. Like when you draw your tangent line at that point, it's kind of a little bit debatable how far you tip it. So there's a little bit of leeway here. So it looks like I'm here at -4, and here I'm at positive 4, so it looks like 8 meters per. I'm the slope here. I'm going a positive 8 meters in 1 second, so that's like positive 8. So you'll notice that I don't have a positive 8 here, and this happens quite frequently when you're doing these graphs. It doesn't work. So you know what? The simple fix to this is make this 8, make this negative 8, and I have to end at 8 meters per second. Now you'll notice right here the slope is a little bit, and we're going to assume that this is an even acceleration, like that. We're just going to assume that. So again, we're going to do the slope of this one. You'll notice that the slope right here is still 0. Now I've got some slope. My slope is, let's see here, 0, and that's 8. It looks like I'm going 8 meters per second over the course of 2 seconds. So that's 4 meters per second per second. So again, this doesn't fit it. So I'm just going to redo my scale, make this a 4, make this a negative 4, and then I go like that. Tricky one. This one right here, exact same way. It looks for my first 1 second, my slopes are all 0. And then here, I have this, and that looks like it's going to maybe intersect right there. So that looks like I'm going 6 meters in 1 second. Because I'm traveling, if you notice here, it looks like I go down. Again, there's my down. I'm going in the negative direction, 6 meters in 2 seconds. So I have a slope of 6 meters per second. So I got to end at a negative 6. So I'll make this negative 6 like that. Assuming it's uniform acceleration. In high school, your acceleration is always going to be constant. You're never going to get a curvy line down here. It's always going to be uniform accelerations. You'll get to that in college. So again, we'll do the slopes. The slope of this part here is 0. And then I go, looks like I go negative 6 meters per second over the course of 3 seconds. So that's negative 2 meters per second per second. So this scale will actually work for me, like so. Because my slope is uniform here. Over this whole interval, the slope is always negative 2. So that's why it stays at negative 2. In the interest of time, I'm just going to skip this one, just because I want to keep this video as short as possible. But you'll have a negative slope, and then here you got 0. So it's probably going to be 0 here, and it's going to be something down at negative. I'll just assume it's negative 6 again, so it's going to be boop, like that. Oh, I screwed that up. It's probably going to be negative 6, but then it's going to go like this. So then 6 over 2 is going to be 3, so I have to go, it's my positive 3, like that. Just quickly going through it. Now, here I'm giving you a velocity versus time graph, and I'm telling you to make the other two graphs. So here we're going to have to do the area. If I go 1 meter per second for 4 seconds, I have an area of positive 4. So I start here at 0, end here at 4. Nice uniform, constant velocity. And then when you go from this one to this one, it's going to be slope. My slope over the entire interval is 0. I'm not getting any faster or slower. 0. Here's another one. I like to color code mine because you'll notice that this one, I'm going in a negative direction. I'm going negative 2 meters per second for 4 seconds. So I have a velocity, or a displacement of negative 8. So you have to be very careful. So I'm going to make this up here at positive 4, and I'm going to end up at negative 4, so I have a displacement of negative 8. And then my slope, is 0 for this graph. I am not accelerating. Here I have when I am accelerating. So this one's going to be fun because it's not a rectangle. So I have to take this area right here. That area is a triangle, so it's 1/2 base times height. My base is 4. My height is 2. 4 times 2 is 8. Half of that is a 4. So I make sure I make it positive. So that means that I'm going positive, and then it's going to curve. Now, in theory, you should make this should have a slope of 2 meters per second, but you do your best. I'm probably getting a little bit steep there. It's not a big deal. As long as you're ending at the right displacement, that's all I'm really looking for when you do these ones. And it's got a curve. It's curving up. And then my acceleration. Here I do have a slope. It looks like I'm going up 2 over 4. So 2 meters per second in 4 seconds is 0.5 meters per second. So I'm up here at 1/2. Like that. Let's do another couple. Here, I'll take my area. Now I'm going to make it blue just to make it negative, just to make sure that this is below the... I'm going in negative velocities this whole time. This means I'm going really, really fast in the negative direction, and then I slow down to a stop. So this is 2 times 3, which is 6. Half of 6 is 3. So I have an area of -3. So wherever I start at, let's say I start at 2. I'm going to end at -3. Oops, I have to end at -3 right there, actually. So, and I'm going really, really fast, and then I slow down to a stop. Really, really fast, slow down to a stop. There it is. And again, if I was really good at doing this, since my velocity at the beginning was -2, this should have a slope of -2 if I draw a really good tangent. Again, I'm not looking for that in depth, but for the master student, that's what that should mean. And again, I'll take the slope of this. So it looks like it goes up 2 over 3. Oh boy, 2 meters per second and 3, so that's 0.6 meters per second squared. So 0.6 is right around there. And notice I'm leaving this last second blank because the graph doesn't go there. So I just leave it blank. This one is tricky. Here's why you can see I start to color code things. You'll notice here I've got a very large positive velocity. Here I'm stopped. Here I've got a very large negative velocity. So what's going on is I'm going really, really fast in the positive direction. I slow down to a stop, and then I start moving in the negative direction and then get faster. It's akin to rolling a ball up a hill. You roll a ball up a hill, it's going really, really fast, slows to a stop, and then starts speeding up as it rolls back down the hill. And here's why I like to color code things, because here I've got a positive velocity, positive displacement, and over here I've got a negative displacement. So let's find my area. My base is 2. My height is 3. So 3 times 2 is 6. Half of 6 is 3. Again, let's see here. My base is 2. My height is 3. So this is the same thing. -3. So what I have to do, wherever I start, it doesn't matter. I have to, in this amount of time, 2 seconds. So in 2 seconds, I have to cover 3 meters. So I'm going to end up right there. And then after another 3 seconds, I'm going to cover -3. So I have to end right there. So a little trick I don't think I've ever told you is you see how this is a positive slope here? If you have a positive slope, it equals a happy face because happy things are positive. And you'll notice here, see how this makes like a happy face? Then you go to this one that we did. I think we did it right back here too. Here's a positive slope, so that makes a happy face. See the happy face? Here I've got a negative slope. Since my slope is negative, that's a frowny face. See the frowny face? Yeah. It's concave down if you're thinking about it in Algebra 2 terms. Concave up and concave down, yeah, this is a negative slope, so concave down. So my slope of this whole business, 3 to negative 3, so I go down 6 meters per second in 4 seconds. That's 1.5. So negative 1.5 meters per second per second. These ones where the velocity crosses the origin are tricky. So here's another one. So I'm starting out with a negative displacement. So 2 times 1, that's a negative 1 area. And then again, 1 times 2, so that's a positive 1 area. So if I start right here, I have to go 1 meter. Oh, sorry. I have to go 1 in the negative direction. So 1 meter negative, and then I go positive 1 meter. Positive slope, so happy. Like that. And then my slope. Negative 2 to positive 2. That's a positive 4 meters per second over, what is that, 2 seconds? So that's 2 meters per second per second. Nice. Last ones. What if I give you the acceleration versus time graph, and then you tell me the other two? So let's do it. Again, we have to go by areas. The area underneath this is 0, so that means that it doesn't change. I could put it right here at 1 meter per second. That velocity isn't changing. I could put it up here at 3 meters per second. That velocity is not changing. I could have put it down here at negative 3 meters per second. It doesn't matter as long as it's a horizontal line. But changing this is definitely going to change that. Because if I did this one, I could put it at 0. Again, I could put it up here at 2, as long as you're standing still. But if I had drawn this up here at 1 meter per second for 4 seconds, now that changes this quite a bit to something like that. I have to cover 4 meters in those 4 seconds. So there's a little bit of ambiguity going on here. So if I did this one, remember my area underneath there is going to be a positive 4. So then this has to reflect that. Here I've got an acceleration versus time, so my area underneath here looks like positive 4. So as long as no matter where I start, I'll start here at 0, and I'll make this reflect my graph like that. So now the area underneath here is 1/2 base times height. So my base is 4, my height is 4. 4 times 4 is 16. Half of that. This has an area of positive 8. So no matter where I start, I'll start it at 0. Oh, I'll just make this 8. Now I'm getting faster, like that. And then my last one. Here it looks like I've got an area of negative 2. So that means wherever I start my position velocity versus time graph, down 2. So now I've got 4 times 2, 1/2 base times height. So this area is negative 4. So if I start it up here, I have to go down in the negative direction 4, and I get faster. Remember, it's a negative slope, so that's a frowny face. So that's why I've got my frowny face. Positive slope, happy face. So that's it. I know it took a little bit longer than what you would have wanted. I'm sure that when you looked at this video, you're like, oh my gosh, 24 minutes. It is very difficult, and I wanted to make sure I did a good job of just explaining all the different scenarios you might come across. So it's going to take a little bit of practice, but please feel free to draw back upon these notes. These notes that you wrote are going to be kind of your key until you can do this on your own. So good luck.